Hello, my name's David Kenworthy and it's the 25th of the 9th, 2022. And today I'm going to talk about Berriman's analysis of historical metrology, introducing pi into the base of the Great Giza Pyramid. And in Berriman's book, he compares the length of the foot in different ancient cultures against the Egyptian Remen of 20 digits. And when he does this, in every case, there are 50,000 digits in the base of the Giza Pyramid. And the first foot that he looks at is the Roman foot, and that has 16 digits in it. And he then compares this to the Roman foot, the Greek foot, which is 25 divided by 24 of the Roman. So that gives 16.666 digits in the Greek foot. Now there is another interpretation. And if we go to the Sivertson-Neal column, we find that every foot that we talk about has got 16 digits in it. Now, this is well and good, but it doesn't preclude this analysis that I'm giving you of the foot containing a variable number of digits. So when we look at the Sumerian foot, which has got 18 digits in it, according to the analysis in Berriman's book, Historical Metrology, we find in the Giza base there are 2777.77 recurring of these units in the Giza base of 36666.666 recurring inches. And we'll find this base in every foot that we look at from all the different cultures that Berriman talks about. He talks about Sumerian feet, Assyrian, Greek, Roman and Egyptian, and also English. He does refer to his Egyptian royal cubit of 20.625 inches being a very English measure. So we start with the Sumerian, and we found that that is 13.2 inches imperial. And there are 50,000 digits in the Giza base, when that is the Sumerian foot, which contains 18 digits. When it contains 18 digits, the actual length of the digit is this, 0.7333. So each one of these feet here is the number of digits in this column multiplied by 0.7333. So that's C8 multiplied by 17777 Assyrian digits in the Giza base of 50,000 digits, which means that there are 2812.5 of these Assyrian feet in the Giza base. We get down to the Greek, and we know there are 3,000 Greek feet in the Giza base from the work of John Neal. We find that the Greek foot is 12.222 inches using the digit of 0.7333, which in this case is Berriman's Shusi of 0.66 inches multiplied by 10/9. Now, I'm not going to talk about the English foot, although it fits. We're going to go down to the Roman, because what we realize in this column here is that we're gradually moving towards pi. When the English foot is used at Giza, there are 3055.555 recurring units in the Giza base. When we use the Roman foot, we're moving to Babylonian pi 3125. And when we use the Egyptian foot, and we know the Egyptians designed Giza against the Seked of 14/11, which is base 7 and base 11, we're going to get, as we would expect, 3142.857143 of these Egyptian feet in the Giza base, and that is 22/7 multiplied by 1,000. And the actual Egyptian foot is 11.666 inches, which is 15.909090 digits. But when it's 16 digits, we get this digit here, 0.7291666, as opposed to this one here, the Roman one, which is 0.7333, which is the one that we're using in this column. So there's nothing wrong with this column, and there's nothing wrong with using this digit against this column. It works both ways. We get the same result. Now, this is crucially important in understanding historical metrology as laid out by Berriman, because both Sivertson and Neal are continually telling me that there are always 16 digits in a foot. Well, there are, unless we use the Remen to determine the length of the foot. And we can see here that if we multiply the Remen by 9 divided by 10, we get 18. And all these are whole number fractions, these percentages here. They can all be worked out as whole number fractions of 20 digits. So Berriman's method is okay. Now we're going to move on now to the solar year giving the cubit in inches. And the original solar year that the Egyptians used was 360 days. And that then went up to 363, 364, 365, 365.25, 366, and eventually they used 366.666 as proof that they understood how eclipses were being predicted. This is entirely in line with Petrie's findings. So the way we work out the cubit in inches from a solar year is very simple. You divide the solar year in days by 17.6. And that is the cubit length. And we know there are 1760 cubits in the base. We can see that 100 inches in the Giza base is representing 1 solar day. So 1 inch represents 864 seconds. And really that's all I've got to say. It's that simple to work out the length of an Egyptian cubit. It's based on astronomical time periods. It's also based on the circumference of the Earth, but I'm not going to go into that here. So that's it for now. Thank you very much.